Question 1, 2, 3 is titled Areas of as a Product and a Sum, and we are going to answer the question, how can I express an area? This lesson covers pages 14 and 15. We're going to read page 15 first, so go ahead and flip over to the bottom of page 15, which has a math notes box. It's really small, so I'm projecting it up there, but you're probably going to have to look at it on the paper in front of you to see it real well. And it's talking about exponential models. Situations that grow by equal factors or multipliers over equal intervals can often be modeled by exponential functions. An exponential function is a function of the form f of x equals a times b to the power of x, where b is greater than 0, b does not equal 1, and a does not equal 0. Note that the variable x is in the exponent. All exponential functions of this form have the x-axis as an asymptote because f of x does not equal 0. Since b to the 0 power is 1, a is the value of the function when x equals 0 or the y-intercept. The base b is a multiplier. Then they're going to give us an example. For example, for the function y equals 3 times 2 to the power of x, the a value is 3 and the b value is 2. Therefore, in the table and graph at right, you have a point at 0, 3. You plug a 0 in here. 2 to the 0 power is 1. 1 times 3 is 3. That's why we have a point at 0, 3. And for each additional unit for the x value, the previous y value is multiplied by 2. So if you take the 3 and you multiply by 2, you get 6. You take 6 and you multiply by 2, you get 12. So each time you're going to notice that the y value is being multiplied by 2 because of that multiplier of 2. To write an equation for an exponential function of the form y equals ab to the power of x that passes through two given points, create a system of equations by substituting one point into the equation y equals a times b to the power of x, and then substituting the other point. Rewrite both of the equations in that form, solve the system to determine the value of a, and then b, like they do right here in the lower right-hand corner. They show it solving for a, then they show it solving for b. Once you have the a and b values, you can plug it back into the equation. If your a is 3.5, the 3.5 goes right there. And your b is 2, the 2 goes right there. And then you can plug in any values and have your exponential model. All right? Flip back over to the top of page 14 because that's the main focus of today's lesson. It says we're going to use a resource, but we're not. They want us to use algebra tiles, but we're not. We're just going to look at one in the packet. So for question 44, it says for each expression below, build a rectangle using all of the tiles. We're not going to do that. If possible, sketch each rectangle and label the dimensions. Write an equation that shows that the area written as a sum, such as x squared plus 6x plus 8 is equivalent to the area written as a product, such as x plus 2 quantity times x plus 4 quantity. If it is not possible to build a rectangle, explain why not. So I don't know if you've run into this yet, but when you're working on the homework, you might be doing a problem and you're like, this doesn't solve, like this isn't possible. If that happens, read the directions. There's often a statement in the direction where it says, if it is not possible. That's telling you that one of them is probably not going to work out. Okay? They're out there. You'll see it more than once in those homework packets. Okay? All right, so we're going to take the polynomial x squared plus 6x plus 8, and we're going to factor it, okay? They start off fairly easy. Notice that the first coefficient is a 1. There's a 1 there that you can't see. If it helps, draw it in. Just know that as these get harder, that coefficient is going to be a 2 or a 3 or a 4. But they start off with 1s usually until you get the hang of them and a little better, and then they start making them a little bit harder, okay? All right, so we're going to take the x squared and fill it into the upper left-hand box, and the third term, which is an 8, and put it into the lower right-hand box, and we're going to factor so that we can get our 6x, okay? But we need to take the 6x and split it between this box and this box, so that they multiply to get 8, but they add or subtract in some cases, if you have negative signs, to get 6x. Okay? Is that possible? What factors of 8 will multiply to get 8, but also add to get 6 at the same time? So in this case, it's 4 and 2, but sometimes you're going to find out that they aren't possible. Later in the semester, we'll learn something called the quadratic formula. Yeah. But for now, they're either factorable or they're not. Okay? So this one is factorable because to get 8, we can multiply 2 times 4. And to add to get 6, we can add 2 plus 4 to get 6. Okay? So this one is doable. And so we're going to factor to x plus 2 and x plus 4. Please note that this x plus 2 can either be above the box like it is right here, or it can be below. It could be down here. So sometimes you'll see it up top, sometimes you'll see it on the bottom. Likewise, this binomial on the left can be on the left, or it could technically be on the right. You're usually going to see it on the left, but I suppose it could be on the right. Okay? Now, how does the multiplying of these boxes work? If you have an x squared right here, the only two things that multiply to get x squared is x times x. So you've got to have the x and the x. X times x is x squared. To get this box of 2x, you need a 2 to multiply by that x that you already know is there, right? And to get this box of 4x, you would need to multiply the x above it times 4 to get the 4x. And then obviously 2 times 4 is 8. Okay. Then over to the right, we're going to write it as a product, meaning what is being multiplied? This binomial x plus 4 on the left is one of the factors, just put it in parentheses. That just indicates multiplication. And the binomial across the top is x plus 2. Put it in parentheses to indicate multiplication. All right. The sum is what we started with. The sum is the x squared plus 6x plus 8. Okay? You're going to end up what? Sometimes you'll start, you should be able to go both directions. Okay. All right, for part B, there are only 2 terms, right? Notice there were 3 terms here. Here, there's only 2. So we're just going to have the greatest common factor of those 2 terms. So I fill in the 4x squared, and I fill in the 4x, and I look for what is the greatest common factor, meaning what goes into both the 4x squared and into the 4x. The numeric part's kind of obvious, right? What goes into 4 and 4? 4. So you write down the 4. Then you look for what goes into x to the second power and x to the first power, and you pull out the x. X to the first power goes into both of those. X squared would be too big. It would go into the first one, but it wouldn't go into the second one. Okay? So you pull out the 4x, and then up top, you're going to write what you would need to multiply that 4x by to get 4x squared. So to multiply the 4x times x will get you 4x squared. And if you multiply 4x times positive 1, you get 4x. Make sure you remember to put pluses and minuses. If you left that plus out of there and you just wrote x1, that doesn't mean anything. Make sure you write x plus 1. Okay, so when you go to write it in factored form, you can put this 4x in parentheses. In fact, let's do that. The 4x is one of the factors, and the x plus 1 is the other factor. So that's factored form. Okay. Part C, we have 2x squared plus 7x plus 1. And let me move it up just a little because I don't want you to have to be struggling to see that. We need two numbers that multiply to get 1, but add or subtract to get 7. It says it's not possible, but here's why. If you take 1 and you multiply it times 1, what do you get? 1. Are there any other whole numbers that you could multiply together to get 1? Is there another pair? We'll get negative 1. But negative 1 and negative 1. Yeah. You could multiply negative 1 times negative 1 to get positive 1. But are there any other whole numbers? Right? There's fractions, but there's not whole numbers. So the only pair really is 1 times 1. Right? 1 times 1. Everybody agree that it's 1 times 1 or negative 1 times negative 1. Okay. What happens if you add 1 plus 1? 2. Does 2 equal 7? Does 2 equal 7? This should be your easiest question of the day. Does 2 equal 7? No, it does not. So this one is not possible because 2 does not equal 7. You're supposed to write down a reason why. You're going to say because 2 does not equal 7. Okay? 2 does not equal 7. They're not the same number. Okay? 1 plus 1 is 2. So that should be a 2 there, and it's not. It's a 7. So that was why that one's not possible. All right. Part D. We have x squared plus 2xy plus y squared. So we take the x squared and fill it in the top left box. We take the y squared and fill it in the lower right-hand box. And we fill in what we know. We know x times x is x squared. And we know y times y is y squared. If I multiply x times y, that gets me 1xy. And if I multiply another x times another y, that gets me another xy. So 1xy plus 1xy equals 2xy. So guess what? This one works out nicely. Not like C. C, 2 does not equal 7, but in part D, 2 equals 2. Right? You have 1xy plus 1xy equals 2xy. So that one's good to go. All right? We take the binomial on the left, which is x plus y, and the binomial up above, which is another x plus y, and we put them each in parentheses. And we can write it as x plus y times x plus y. Does anybody know a shortcut way to write that? Right. You could say x plus y just one time, but put a little square. So it's squared, meaning multiplies by itself. Okay? Or you can write it like that. The way I have it is fine. Either way. Means the same thing. Okay? Any questions on A, B, C, or D? Okay. So question 45 shows us some algebra tiles. Raise your hand if you've worked with algebra tiles before, either the plasticky ones or on CPM on their webpage. They have some algebra tiles that you can move around and you can click on them to make them positive or negative. Okay, good. All right, awesome. So that's what this is a picture of over to the right-hand side. This one makes a perfect rectangle. When your algebra tiles make a perfect rectangle or they make a square, you're going to get an answer. You're going to get A, B, or D, right? It's going to have factors. It's going to be factorable. But if your algebra tiles will absolutely not make a rectangle